Hi, Jalen. My name is Blake. I use they, them pronouns, and I'm here to help you with this question. I'm pretty sure that g of x is supposed to be written like this. Hopefully that's true. If not, then maybe I can read you the question. Anyway, so the first part is that we were supposed to graph this function f. So let's just go piece by piece because this is a piecewise function. So f of x is equal to 0 if x is less than 4. So let's find -4. We're going to put an open circle here. And then f of x is equal to 0 for everything less than 4. So that's the first part. Check. The second part, f of x is equal to 2 if -4 is less than x less than +2. So let's just start at x equals -4. We're going to graph starting from here with an open circle because they're just plain old less than signs to here with an open circle. So this is just where y equals 2. So that part's done. The next part is 4 minus x if 2 is less than x, which is less than 5. So this is definitely the equation of a line. So all we need to do is evaluate the endpoints of the interval and just plot those points and then just draw a line between. So, so x equals 2. F of x is 4 minus 2, which is 2. So that point is already there. And then for x equals 5, we get 4 minus 5, which is -1. So the other point is 5 comma -1, which is right over here. So here's a straight line that looks like this. Wow, that was a really good freehand. Boom. Okay, and then the next part is f of x is equal to -1 if x is greater or equal to 5. So starting over here where x is 5, we get that f of x is -1 already. So we'll just fill in this circle. This is greater than or equal to. And then from there, we get -1. So that is our graph. Now, g of x is asking for the area between from x equals -4 to x equals whatever our input is, right? So in this case, our input is -7. So it wants the integral from -4 to 7 of f of t dt. But between -4 and 7, the area under the curve is just 0. So the answer for this is just 0. For g of 2, this wants the integral from -4 to 2 of f of t dt, which this would be the area under the curve from -4 to +2. So we can see under the curve, we have this rectangle, right? We have this rectangle. And the base of the rectangle is 4 units plus 2 units, which is 6 units total. The height of this rectangle is 2 units. So the area under the curve is 6 times 2, which is 12. So that's for g of 2. And then for g of 7, we're going to continue getting the area from -4 to +7 of f of t dt, again, just using simple geometry, right? But we have to be careful when the graph goes below the x-axis. The areas under here are going to end up being negative. So we're going to add those negative areas to whatever we get to in the positive areas. So again, this first part, this first rectangle has an area of 12. And then over here, here's a right triangle. And the right triangle has height 2, right? And then its base is also 2. So, so the area is 1/2 times 2 times 2, because it's 1/2 times base and height. 1/2 times 2 times 2 is just 2. So the area of this part is 2. And then you can see this little tiny right triangle over here, and it's below the x-axis, so our area is going to be negative. And this has a height of 1 and a base of 1. So 1/2 times 1 times 1 is just 1. And this is negative because it's below the x-axis. Finally, there's this little stretch over here to where x equals 7, and it's this rectangle, right? The base is 2, and the height is 1. 2 times 1 is 2, and then this is a negative area, so this is negative 2. Oh, excuse me, this should be 1/2, negative 1/2 over here. So if we add all of this together, we get 12 plus 2 is 14, minus 1/2 is 13.5, minus 2 is 11.5. So that is the answer for part A. I didn't include all the other evaluations because there's just not enough time. For part B and part C, what we have to realize is that if we take the derivative of g of x, by the second part of the fundamental theorem of calculus, we have that g prime of x is simply f of x, right? All we had to do was just substitute x in for t, right? And so that's by the fundamental theorem of calculus part 2. Technically, f was supposed to be continuous, but there's some other technical stuff that lets us get away with just saying this that I don't really have time to explain. So now we've got to look at, because this is literally the graph of the derivative. So we want to see where the function is increasing based on where the derivative is positive. So over here, we can see that the derivative is positive, right? So the function is increasing over here. So this is from -4 to +4. Okay, and then the last part, we want to see where g has maximum value. So to find the maximum, you want to see where the derivative is equal to 0, and that's your critical point, right? So over here is one part where the derivative is 0, right, where f of x is equal to 0. And then over here is another part where f of x is equal to 0. But notice that g of x, the area, is 0 at this point, and the area is 14 at this point, which is the maximum we're going to get. So, so g has max value at x equals +4. Okay, so I hope that helps. This video ended up being kind of long, but I hope that it helps, and I hope you have a great day. Thanks so much.